name is Russ Festino. I'm a developer advocate for Algorand. Okay, so let's go ahead and get started. Blockchain for developer. Talking about innovations here, right? We got, what is blockchain development all about? And on the poll question we got there is your experience level with Algorand blockchain, more than 6 months or more than 6 months with any blockchain. You can pick up to 2, I think, on this one. And then also other choices there. You can see brand new or, some more experience. All right, so what is blockchain all about? That's a big question. A lot of times you getting started, developers do want to know also, why do I care about blockchain and what type of solutions can I build? Probably of most interest, right, for Hacker Earth. And then also, what programming languages can I use to get the task done? What are smart contracts? How do they work? How do I do those? How do I create dApps? And, what's an AVM? What's that all about? The Algorand virtual machine. And how do I verify smart contracts? In other words, in audits. So the agenda then, what we're going to cover today are blockchain basics and use cases. We'll get you going on, what kind of things have been done in the past with blockchain. What's layer 1 all about? Also getting started. How do we get going, building the applications and the code and tools that I need to do the job as well. We also have blockchain use cases coming up here now with the blockchain. So with blockchain, basically there's 3 things primarily. One is the fact that it's decentralized, which is the opposite of centralized. That's right. It seems like every day we hear about ransomware attacks on centralized data stores, and there's a lock and key to get in, and many times hackers will figure that out and then hold the data centers hostage in ransomware attacks. So one thing that prevents that is being by decentralized. So there is no single point of failure on your system. In fact, it is decentralized, and there is no authoritative group or authority that will facilitate usage. And then also the fact that it's distributed, it's worldwide, nodes all over the planet. This really helps also in the stability of the blockchain and the ability for it to be up and running. We've been running mainnet now about 2.5 years, and we've had not a single outage at all whatsoever on this blockchain for Algorand. Finally, third piece is it's immutable, and this is a very important concept. Basically, it's a read-only ledger. You write once, and when new transactions are written and recorded to the blockchain, and then after that, you are cast in stone. Basically, there's no way to change prior data, which is very, very important, especially if you start hearing about other blockchains that are able to do that, or able to make tweaks or whatever to data in the past. That is not the case here with Algorand. It's with our consensus protocol. It's very easy to determine if there's been any tampering along the way. So that's the real high level on a blockchain, what it's all about. So just to think of it as a distributed, decentralized, immutable ledger. In terms of the record types, for those that are database types out there, maybe to understand this a little bit better, it's really not that complex of a ledger. You start out with blocks. These are basically points in time. In Algorand, we burn blocks every 5 seconds, and on that block are the associated transactions that occur during that time interval. And what we have then is transactions are between accounts, the sender, receiver. And each account also has relationships and holds assets as well as applications, both in the opt-in and creation varieties. And that's really it. That's a very, very simplistic view of what the data is on the blockchain. So what types of blockchain solutions can I build? I know when I first started learning about blockchain, I was a little bit confused on this. I'm thinking, well, gee, this is a public and open blockchain. Does that mean I can only create public and open solutions? Like you see in the upper right corner, currencies, betting, video games, these are all applicable solutions for that type of scenario. And then in the upper left corner, you get to public and closed. So that's an example where voting might be appropriate, and voting records and whistleblowers. These are, are public because you want the public to see the results. Then maybe you don't want to see them right away. You want to wait to a certain time of day to display them. And then the public and private ones on the bottom there, private and closed, private and open. These are, more secure, right? Supply chain, government financial records. And on the left, you got, construction, national defense, military tax returns. Well, all of these are applicable to Algorand blockchain. And that's because what you can do is build in authentication on layer 2, be able to provide access and any of the requirements you have from a secure standpoint for your solution that you're building. We have things like the note field, which is a free form and allows you to put any structure in there on the transaction. We also have smart contracts to help facilitate managing that process as well. So it's up to you and your developer staff to come up with the appropriate authentication and privacy rights for your solution. But certainly, these are all doable on the blockchain. So we got El Salvador government. They're launching, Algorand is going to be launching your app solutions on Algorand to take care of all the government records, right? So we saw that on the prior slide as a possible solution. So this is really great news. That's pretty big, when governments start getting in on board on your blockchain. Also, some other solution examples. Circle is the power of stable coins next generation. We have USDC, which is a stable coin. For those who aren't familiar with stable coins, basically native cryptocurrencies tend to fluctuate a lot in price. One day they're way high, then they're way low. That really makes it difficult to do transactions with them. So what USDC is these are tied to a current fiat, in this case USD, and they fluctuate with the economy. So it's much more stable, hence the name stablecoin, and over 2.9 billion of these in circulation. Yieldly is a multi-asset staking and cross-chain swapping on Algorand. So this provides bridging, staking, and no-loss lotteries, as well as Lumi chose Algorand to power crypto payments. Works with any standard ASA standard assets, which is our tokens, or native tokens that you can create and exchange. I'll talk more about that in a little bit. And any future central bank digital currency as well, built on Algorand. And then you get to CA, the Italian Society for Authors and Publishers. They've launched more than 4 million NFTs on Algorand. This is a great idea in the way of copyrights. So copyrights are very, very big. And this is really, an industry changer. This is the way copyrights are going to be done in the future. There's no global boundaries. All of these artists have copyrights represented globally, and they are etched in stone. So this is really a game changer in terms of use cases for blockchain. Very good stuff there. All right, next up. Oh yeah, they actually did a skit on Saturday Night Live. Those are familiar with that show. Few weeks ago on NFTs. So, we've hit the mainstream, on non-fungible tokens as well. So good stuff there. Other use cases, you have tamper-proof charity organizations, including, the China Ministry is using blockchain to improve transparency of social services, tracking of all donations and audit trails, also voting tamper-proof. Is a really good solution. Again, there's no second guessing, what the votes are. It's tamper proof. Healthcare, global access, medical records. That's really nice. Every time you go to a new doctor, you got to spend a half hour filling out new records, right? And giving your history. Why? You should be in control of your own medical records, right? And just point them to something saying, hey, these are mine. Here they are. Boom, we're done. Let's go ahead and do the visit. So then automotive as well, very good in terms of supply chain visibility, like visible, any supply chain solution actually for that matter is a great solution to build on blockchain, where you have many checkoffs along the way and they have to be signed off. The old days of signing off on paper, then converting that into electronic format, those are fading real fast, and this is a much more efficient way to do it. Not only that, what they're doing is putting sensors into vehicles, and this is facilitating data that's written right back to the blockchain around the wear and tear of spare parts and things of that nature. So very cool stuff being done there. But by far and large, the biggest area is DeFi or distributed finance up on blockchains. In 2020, it was over $1 trillion in cumulative blockchain network value, and that's projected to be a lot more this year, about 3 trillion. So mind-blowing numbers there when you think about it. So we're in a brave new world, right? And all of these, companies and organizations are really part of the ecosystem, which is really growing leaps and bounds in Algorand. You can see all the technical companies, all the financial companies, as well as ecosystem of applications, lots of apps being built. A lot of partners and a very strong ambassador program representing over 60 countries with 500 plus ambassadors. So to wrap up with the Algorand pure proof of stake protocol, it facilitates true scalability. There's no mining on here, there's no waste of energy, and it's lickety split quick, under 5 seconds for blockchains. And these numbers are all getting better, by the way. It's going to have higher throughput, up to 40,000 is what our goal is, and we have under 5 seconds right now, and that continues to go down and get faster. And that's pretty good to do that as you get bigger, right? So infrastructure longevity as well. You got technical flexibility, a lot of SDKs, a lot of REST APIs and tools being built. Transaction certainty, there's no forking at all on this blockchain. So once you write a transaction, it's committed to the blockchain. Platform extensibility, as well as very green, right? It's very energy efficient. You can actually run a node on a Raspberry Pi. So very, very efficient. And so that's another very positive thing that I've seen here and a lot of good reception to in the industry. Cost efficient. This is really cool. I mean, if you take a look at Ethereum, could be just $20, let's say, just off the hat for a transaction. Well, in Algorand, it's a 20th of a penny. So it's a big difference there. And that's also attracting a lot of vendors to create solutions on blockchain, because it really makes sense from a cost standpoint and provides true security, as most blockchains do. But this is really tried and true here with the Algorand blockchain. So let's talk about layer one. This is the heart and soul of your solution, and many different aspects here in terms of Algorand accounts, standard assets, ASAs. You got atomic transactions, smart contracts, and indexers. Let's talk about all these in depth now for this section. So with standard accounts, basically this could represent an individual or a company, and also you have multi-sig, which will facilitate a group of folks that want to sign off on a particular transaction. And all you do is set a threshold. So say you have 10 in your group, you could say, oh, the threshold, I don't know, if 3 of us vote on this, then that's enough to satisfy. Or you decide, whatever is applicable for the application you're building, that would be the threshold that would be needed for a sign off on sending funds. And then also have a logic sig, which is basically a smart contract. If it returns true, it'll go ahead and sign it and send it, as well as if it's false, it won't. So very, very simple in terms of the type of accounts, but you should know there are those 3 types. Also, let's talk about ASAs then, Algorand standard assets. These are both in terms of fungible tokens and non-fungible tokens. So on the fungible side of the house, these are tokens that are all of equal value. They are all have the ability to go ahead and create things like stable coins or things like cryptocurrencies. You can create your own cryptocurrency. I can create a Rust coin if I want to with ASAs. Also, you have restricted fungible tokens as well with clawback and freeze capabilities. Then you take a look at the NFTs. These are unique. These are individually unique. So like we talked about before, copyrights, right, fall into this. Certifications fall into this category. Real estate is another good example. You have, maybe a 2-bedroom condo in one part of town and a two-bedroom condo even across the street, as far as that goes. And they would have different values, because one may have a completely renovated inside. The other one might be, you know, very old and need renovation. So there's a lot of metadata that's associated with each one of these that makes them unique. And so the NFTs are really a good way you can think of them as they're collectibles, like baseball cards. And then you get restricted non-fungible tokens as well, with the ownership registries, again, with clawback capabilities. So that's kind of like the big tour on ASAs. And then also, let's show you how you can create these. So this is our first demo of the day. Let's go ahead and bring up this page here. This is a Algodesk third partner utility to create ASAs. Let's do these again. These are our three different networks. We got mainnet, betanet, testnet. We'll go ahead and connect our wallet, and you got three different wallets here right now to choose from. You got Algo Signer, you've got the My Wallet, and Algorand mobile wallet. So I'll go with Algo Signer for this demo, and let's go ahead and choose this one here. And now we're going to go ahead and create an asset. And so this is where we're going to call it pizza Russ, and then total supply. Let's go 10,000 of these. Let's go at 1 decimal point on these. So if you did want to create a, you know, a fraction of the URL of the asset, you could do that with the decimal points. And then you also have your ability to put URL in here. And then you also have the ability to put in, you know, management roles. What accounts would you want responsible for reserve, managing, freeze, and clawback? And you also have the freeform note field. And I figure it's appropriate to talk about, you know, pizza. You know, Zal was actually the first transaction on Bitcoin. He finally got somebody to bring him pizza in exchange for, you know, Bitcoin. And that was really, and then the rest is history, as they say after that, right? So that is the little bit of history there for blockchain, folks. I hope I didn't fat finger that. Looks like it is going here. I'm going to wait for the confirmation, and then it should go ahead and write this out to the blockchain. So there it is. So now we've got our pizza. You can see over there on the left, we're going to view this transaction. This brings us out to Internet Explorer. Excuse me, Internet Explorer. Oh, boy, look at me. Algorand, Algo Explorer. So again, this is a great tool to take a look at any asset on the blockchain, as well as all the transactions. And there are different blockchains as well. You can go ahead and bring up, do another one here with, let's go Goal Seeker, for example. So these are great tools. So, you know, you saw this instantly happen, right? So these are up here instantly after you do a transaction, and you can really search by anything. You can search by address. Comes up with all the different pizza demos I've done. You've got a lot of other information about block information and all the transactions that were written during that time interval. So a lot of great information there as well. So let's go back out to the deck. And so let's say you want to create an NFT, right? So let's go ahead and show you that as well. So what we're going to do here is we are going to go ahead and do this visually. And this is by Origin Mint. We're going to launch this app. And we're going to go ahead and use Algo Signer to go ahead and sign this off. We'll use this bottom account here. Let's go ahead and mint this. And let's call this Mario. And there you go here. I went to a blockchain summit this weekend in Tampa. It was really great. And there was a lot of artists there, you know, in vendor booths, and they're doing stuff like this, and they're you know, minting their artwork on a blockchain. It's a very exciting time for artists and musicians. You know, it's a whole new era on how to do things for, you know, protecting your applications and making money, you know, with them as well. So it's pretty cool. So now let's go ahead and mint the NFT. And so now once this gets written out to the blockchain, then you see it's been successful, and boom, there it is appearing in your list. So some pretty cool stuff there on doing minting and assets. The next section here is almost succeed or fail for atomic transfers. So this is a great thing. You know, a lot of times when you do business transactions with people you know, it gives you a good feeling, right? Because you can kind of have some kind of trust there. You know, the old saying, you know, who would you rather do business with, someone you know or someone that you don't know? Well, really the problem with with people that you don't know is you can't trust them. You don't know if you pay them 50 algos for a concert ticket whether they're going to deliver on that or not. And it's been the problem with things like Craigslist and things of that nature. Well, here, what we're saying is person A is going to send 50 algos to B, and person B is going to send the concert ticket. But if person B doesn't send the concert ticket, person A doesn't lose the 50 algos. Both of these things have to happen, or none of them do. So it's easy and secure, guarantees an exchange of goods, and combine these other Algorand technologies, including just standard assets and smart contracts. Some examples. Things like efficient match funding, enable multilateral trades, circular trades, group payments, combinable with other layer one features, and the distributed payments, all a part of the mix. So what about smart contracts? So smart contracts, let's begin with exploring smart contracts with a quote from an inventor himself in 1994. And Nick Szabo wrote, a smart contract is a computerized transaction protocol, and that executes the terms of the contract. His original writing is described as a simple vending machine dispensing a cold drink only if sufficient coins were provided. Very, very analogous, right? And he goes on to describe cryptographic systems that would prevent theft of property. So way ahead of his time, and really great stuff there. So what we have here is basically the smart contracts for Algorand. You have transaction execution approval language, or TEAL is the short name for it. It's an assembler-like language. Assembler is important here because it's very, very efficient. You can't get more efficient than that. And efficiency is very important when you're scaling the way Algorand is scaling. And so that's always in the first and foremost of our minds of our engineers that designed the Algorand blockchain. To make it a little bit easier, there is a Python-enabled compiler that you can generate TEAL with. And so you can do it in Python. So we had some Python developers out there I noticed before, as well as Reach is another great tool that the ecosystem has provided us in writing distributed applications as well that generate TEAL as part of it, plus an entire distributed application. So then we have smart signatures. These approve spending transactions, and then also smart contracts, which can actually generate transactions themselves and provide global storage through the entire blockchain or local storage at the account level. These are all combinable with Algorand technologies of atomic transfers and ASAs, and you can combine together smart contracts and smart signatures too. So this is a dApp architecture, distributed app architecture. So you have smart signatures, perhaps doing some signing. You can use the Algorand SDKs, APIs to do this. And then you have different transaction types that are supported: payments, assets, applications. And then you have your fungible tokens or non-fungible tokens. These certain payments are between accounts. And then you also have smart contracts then, which would be the applications, right? Providing information either to local state or to global state on the blockchain. Finally, we get to Indexer, which is a really great way to report. So anybody building solutions out there in this hackathon for data from the blockchain, like reports or dashboards or things of that nature, this is what you'll want to use. Provide support for all the 4 built-in SDKs that are supported by Algorand: the Go SDK, Java, JavaScript, and Python. There are more SDKs in the ecosystem: C#, Dart, many more. And what this does is basically it offloads the data to through the AlgoDeep process into a PostgreSQL database. So it's a real database that you would have to do queries with instead of a ledger. You can certainly do queries on the ledger. It just might not be as time efficient as doing it through Postgres database. So we give you a few options there, and there's a lot of API services that are around as well. So you don't even have to create your own service to do that. the two folks that those two browsers I showed you, PureStake and Algo Explorer. Those are two that Rand Labs has some API services you can do go into the developer piece of those sites. So let's bring it back home here and bring it all together and how these architected, how you architect an app, right? So this is a solution, for example, on voting. So you have the voting commission and the spending token. Now these are all going to be atomically grouped. Okay, all of this works or none of this works. And then you have vote for candidate A. You got a voting smart contract, and then this is going to then increment candidate A vote total to global state because you want everybody to be able to see this at some point. So there you have it. And then also you have combining layer one features with crowdfunding. Same thing. You got the this is where you have an inventor has a chess set or something that's brand new they're going to come up with, and they need to raise funds to meet the predicted production costs to do that. So if enough funds are raised, then the investors will get the chess set. If it's not raised, then everybody gets their money back, and you're off and running. So again, a great example of doing it. We have examples of both of these up on our developer portal. How about getting started? We got the Algorand sandbox, Algorand SDK, VS Code plugins. AlgoDia is a great IDE we'll be showing you here in a second. Indexer, Reach as well. So with Sandbox, very, very easy. You install GitHub, and then you just clone the GitHub repo for Sandbox, and you're off and running. Now, what this provides you is a very quick way to set your own node up. And basically, it runs in a Docker instance. And if you just put, in the command line there, /sandbox up, it'll go ahead and bring up a node for you in the private network. So private network is actually a fourth network, right? This is like your own personal network, the way I like to think of this. So the three we've already mentioned were BetaNet, TestNet, Mainnet. You can also bring those up in the sandbox just by putting the name in after sandbox up. So very good stuff there. And then I'm actually using that in these demos here. We'll point to that and we'll show you that real quick when we get there. The nodes, you can develop your own. It's really easy to do now, and fast SketchUp is here. So you'll have it within some minutes. Used to take several hours or days, to sync up. Also, you can do this on Mac. You might do Windows and other Linux distros as well. Then you also have API services, like I alluded to, from PureStake and Rand Labs through index and archive nodes, and you just access from SDK code on the platforms that do not have nodes. So you don't even have to run a node to build solutions with. Sandbox is really great for testing and not for production. Really, it's a nice snapshot from the current node. There's no sync time whatsoever. On the code tools, all these are provided by Algorand. The rest that you see are all in the ecosystem. So really strong ecosystem shaping up. And you can see the other SDKs there: Rust, PHP, Dart, C#, Swift. There's actually a new Unity SDK, and after this meeting gets done, I'm going to be checking it out because I gotta look at a tutorial that was submitted by one of the members of our community that wrote that up. So I'm really looking forward to that. And Unity is very, very big for game development, and we also have some sizable bounties revolving around game development. So that's pretty cool. And then we take a look at Algorand, and let's go right out to the developer portal for the Algorand developer portal. If you scroll down here, you can see you've got, starting out with blockchain basics. Many folks coming in are first timers, like many people that are on this call. So these would be good articles to go through. And then also you have smart contracts and dApps, build with Python, tokenization, creating NFTs and fungible tokens, real estate. I had at that conference I was at, it was at the Florida Bitcoin and Blockchain conference on Friday when I did a presentation there. But I was talking in the hallways to vendors, and this one woman comes up to me, and she's a realtor, and she really wants to build a real estate application. And I pointed right here. Oh, here it is, real estate. Oh my God. She goes, oh, that's great. So she's going to go check into that for creating security tokens, using that. Then also you have integration with other ASAs and then all the SDKs down here at the bottom. Now, under the docs, you can see over here, you've got many getting started areas. Any area you want to dive into, you can go and keep going. Then you got deep dives into a lot of those as well. And then you have information on each one of the SDKs and getting started with each one of these. I'm going to show you actually this one here, your first transaction in Java. We're going to go ahead and actually walk through that in a minute. And then at the end of these, you also have links to replets that are out there that you can actually run the code. So you can just bring this up and it'll go ahead, and you don't have to install anything. All you got to do is, once this thing loads up, is hit the run button that's up here, and you'll see all the information display here in the console as it's running. So great learning tool, really, really cool stuff there as well. Also, you also have tools, and there's many in the ecosystem. So you can spend some time in this area. A lot of monitoring, analytics. You've got Discord. I encourage you all to join Discord. You've got great support there, right, on the developer forums. Blockchain explorers, wallets. Many wallets now are surfacing up, all the SDKs in different environments. There's the brand new Unity one. And then you got smart contracts and utilities. So a lot of good stuff there. And then metrics, as well as a link to Discord. So some great stuff there on this as well. All right, getting back out to the deck here. VS Code, for those that like to use VS Code for your editing and writing environment, you see we've got extensions. Just type in Algorand there and you'll find them. So show me the tools. Let's go ahead and do some demos here. So first thing we'll show you here is I've got the sandbox up and running here, and I did a start sandbox earlier today, and there it is, up testnet. So I'm running testnet, and in here you'll see addresses and tokens. You need to pass these into the various daemons to have access from your SDKs. So let's take a look at our first SDK, which is going to be in the Java transaction, the one I pointed you to, the REPL. This is the same code that we walked through in there. So let's go ahead and run this. And this will walk through basically the thing you need to do for any language that you want to utilize. So we're going to do two things. We're going to go ahead and create an account, and then we're going to do our first transaction. All right, so to create an account, let's go ahead and dispense some funds to it. So we've created an account that you see listed in this URL. I'm going to go out to a dispenser. So this is testnet, so you can go ahead and get some free fake algos and use those in the testnet environment to test with, right? So mainnet, you'd have to, fund an escrow account or something and fund your application from those. So here you go. So now I've got the transaction ID complete. If I go back over to the application again, I'm going to head and continue on here. Now I've got some funds in there, and now I'm going to create an instance of my client. So this AlgoD client is going to take in that API address we have up there, the local host like you saw in the sandbox, and I'm going to use that client. And then once I have that client, I could do things like get account information. Here we're going to get the address of the account, and then we're going to get out the amount field, like how much do they have in that account. And you should see the balance come up there. This is 10 algos. These are in terms of micro algos. So when I did the dispenser, it dispensed 10. So that matches up. And then the next thing we're going to do is an actual transaction. We're going to go and execute. Here we've got the receiver who's going to get the funds. We've got the response for the parms we're going to do. But then here's the body of the transaction. Things like the sender. This is going to be who signs it as well. And then you also have the note field, the amount, the suggested parameters. If you take a look at the parms, there they are coming up. You can see it's going out to testnet is the Genesis ID. And then we have a close too. We're going to bring everything back to the dispenser when we're done here. So there's going to be a zero balance at the end. And all we're going to do is go ahead and hit run here. And then once we do that, then we can see what the transaction is by sending it the transaction ID. So we're signing it. So now there's 3 steps, right? You create the transaction, you sign it, then the last step will be down here, will be to broadcast it to the blockchain. You do that every language in every scenario, those 3 steps. Now, if you're going to have an error, it's going to be on this step. It's going to tell you got insufficient funds or whatever, if there's a problem with that. And that's the consensus protocol built in doing that. There's a wait for confirmation method that's called, and actually that's going to be built in now to many of the SDKs. And then also you can see you've got the account information then showing up at the bottom. So we were successful in that, sending that amount over to the blockchain. There are the transaction details. Okay, so those were a few of the demos. Another one here is going to be Algorand, and Algorand is really a great tool. So let's go ahead and just hop right into it and show you the type of things you can do. We're going to show you smart signatures as part of this demo. I'm going to go ahead and bring up the Algorand environment. What's nice about it is you have ability to manage all your nodes. I got several nodes I can access: mainnet, testnet, pure stake, local, and really this is great to be able to have that kind of capability. And then also you can see you've got, you can create a new account, you can list accounts, you can see all the accounts that are in here, and fetch balances on each one of those. If you wanted to do a new one, you could do that right here on the fly, all visually without any code. Okay, so that's an important takeaway. What we're going to do in this demo, this is Teal that you see running here behind me. It's a very simple program. It's going to say, okay, the receiver must be Bob's address, and it's got to be less than or equal to 1 algo. And so that's the simple test that we're going to do here. So we're going to take this Teal, and we're going to go ahead first, generate a logic sig. And that is actually a smart, stateless smart contract. And let's go ahead and send the create a logic sig from the stateless contract. We're going to make this a delegated signature. So not only does that logic have to return true, but Alice has to also sign off on it. And then now we've got this LSIG up here that we created. So let's go ahead and just send this transaction. Now, the first transaction I'm going to send here, I'm going to send it to one of these other accounts, like this RAF demo account. And this is going to fail. I'm going to send in one that's required because it's not going to whose account? It's not going to Bob's account. So you'll see that right down here, rejected by logic. And if I do this according to the logic rules, then you can see here, I'm going to go ahead and send this transaction again, but this time we are going to make the receiver Bob. And again, I could, force the arrow by putting in something other than 1 here or 10 or, something like that, something more than 1, but let's just go ahead and do this. And now it's going to go ahead and successfully sent, you get the message down there below to the blockchain. So very quick demo on that. And I think you'll get a lot of use out of that when you're building your supplies. All right, we do have REST endpoints for anybody who wants to use like tools like Postman or PAW. You can see those on our REST endpoint page in the documentation. Now, how about Reach? Reach is a very cool program. I actually, this was what I did my demo on at the conference on Friday. It was really well received, man. People were blown away with A, the Algorand blockchain, and B, how easy it is to build dApps with this tool. You get the front end and the back end here. So traditional client server architecture, and the back end is in JavaScript like Reach code. This provides the interfaces for the front end as well as defines participants and verifies and makes commitments. So verification process is extremely important. That allows you to not leave money on the table or have any loopholes in your smart contract that are going to lose funds. Then on the front end, this is where you do things like actually put the meat to the interfaces of the functions that you've defined back in the back end, the interfaces. So this is actually has the code in it. And then you have the ability to create accounts here and the internet method logic, like I said, as well as any blockchain specific code. And then you compile and run that and deploy it out to the Algorand blockchain. And what's nice too is you can deploy to multiple blockchains as well, Ethereum and I think Complex is another one. It's an all-in-one tool as opposed to other environments that require more than one tool to do all these different steps that are needed when you're doing a blockchain solution. So protocol design done in the Reach programming language, smart contract through the compiler, middleware through the API. You've got the front end with JavaScript, and now you have RPC languages support, Python, Go, and they just introduced C# as well late last week, testing with reach run verification. It goes through formal methods, right, that you can look at for in every reach compilation. Does a thorough formal verification of the dApp using SMTP, SMT based theorem providers. And finally, deployment. You can just do compiler configurations to go to multiple blockchains. So I'm going to show you this through an example of Mora. Mora is a game that is like you throw fingers out, two opponents. One would be throwing, say, 2 fingers. The other one throws, say, 3 fingers. And whoever guessed 5 would win. If neither guessed 5, you would continue doing another run. So I'm just going to go ahead and do a reach run here. And this is going to go ahead and give us a game, and then we're going to talk about the code that's up there. So we got a little betting going on. So the wager is 5. I've got a little print statements going on here to log information on the back end. And in this case, Bob wins because let's take a look at this last run here. Al shoots 4 fingers. Bob shoots 4. 4 and 4 is 8. Bob guessed 8, so he won, and he gets the wager, so it goes there. So to give you an idea on the verification process and how this would fail, I'm going to go into the backend program, and I'll describe this in a second, but I'm just going to change this to 1 instead of 2. So this is both wagers, right? Would normally go to the winner, whoever, Alice's wage and Bob's wage. So it's wager times 2. If I do times 1 and I run this again, you'll see that this gets validated, and it's going to complain saying, hey, you got money left on the table in here. This is, how big problems have been, caused in the past for this exact scenario right here. So you can see here that this is only going to be 1, and the balance 0 application exit. That theorem is false. And the way you get to those is you put a lot of asserts. Now, some of these you get automatically without doing inserts, but the more asserts you put in your application, this actually goes through a loop of doing the winner logic, which you see right down over here, right? There's a function down here for the winner logic. And then what you can do is also define the interfaces for the front end. So this is the makeup, right? So you got asserts, and then you got your interfaces, and then you got your participants. So you got Bob and Alice. You have a player defined up here with the functions that are common between them. Both are going to throw fingers. Both are going to get a guess. Both are going to be able to see the outcome. Timeouts are very important too that we have in here because what happens if Bob doesn't accept the wage that Alice makes? Well, if it doesn't happen with a certain amount of time, she wants her money back. She doesn't want to lose it, right? Which would happen if you didn't have the timeout in there. And then you have a while loop going through until there's a winner. And then also you have this make commitment. This is going to hide Alice's guess because Bob would have an unfair advantage of seeing that. So really well thought out. You can see here it's unknowable to Bob what her values are. Then Bob goes ahead and throws her fingers, and Alice uncommits them, and then they go ahead and publish it and play it, and boom, you got this out in the blockchain. On the front end, that was all back end we looked at. And on front end, then what you can see is I've got code here that actually will start the standard library. And then from that standard library, you have all the functions available for parse currency. You can have blockchain specific code like you see in the comment here. If the connector is algo, then I'm going to make this value 3, otherwise I'm going to make it 10. And then you have test accounts you can create here. This is all in the private network with those balances. And then you can go ahead and do functions like get balance like we saw in the SDKs before. It's all very easily done here. And then you have the logic. This is the random number logic and get fingers. This is the random logic and getting the guess. And then you have the promise that goes ahead and kicks it all off. And then afterwards you get done, you see the final balances that get displayed. So that is very cool. And then the last piece here, I'll go ahead and show you, is talking about the AVM. So what is an AVM? As the Algorand virtual machine, once again, is what it stands for. The consensus network observes when a smart contract app calls a transaction. So it sends it to the execution environment, and the execution environment is commonly known as a VM or virtual machine. And then it's a runtime basically that runs within the consensus protocol. And smart contract program logic is executed and evaluated, and either includes a transaction in the next block or it discards it. So this is happening on every node in there. So we got more information out on our developer. We're going to give you the link to this deck in a few minutes. And then also you have the a great video on our site. We have a developer office hours every other Tuesday. This is one of them that was all about the virtual machine. In PyTeal development, you create the solution in Python, you compile it with PyTeal, and then you have bytecode that could be used for your calls out to the applications. And in short, basically, this is the Python. You do a compile to text, and it compiles out to the teal, which you see right there. So let's take a look at this. I've got last demo of the day. Bring this up. All right, so this is written in Python, this solution. And if you take a look at what I'm going to show you here, this is the PyTeal, first of all. And we're going to sing a song here, one that many of you are probably familiar with, 99 Bottles of Beer. In fact, there's the lyrics right there. If you don't know them, we're going to demonstrate logging through the AVM here. And in doing so, we're going to teach you a few things. One is we're going to check that the app is call sender is the creator of the app. So that's what this statement does. Then we're going to create a scratch variable for the iteration. That's the I in a for loop, and you're going to give the upper and lower bounds here. From 99, we're only going to go down to 97 today. Okay, and then you got the iteration. We're going to go ahead and load in. That's the for loop itself. And then this is the sequence. You want to go ahead and do that. This for statement, and until you get to the iteration completes, and you're going to go ahead and pull one out and sing that song. Down here is the boilerplate code that says, okay, I'm going to go ahead, and no-op is the call to the contract, and you see the log right there. This is the one that gets executed right there. So that's the PyTeal. And what if you ran that, what it would generate is this. This is the code, right, that it generates. So let's run this and make use of this in our application. So we're just going to run this solution. So we're going to wait for this confirmation to occur, and then you can see over here on the bottom, you're going to see the actual lyrics come out, and you can see here we're doing the same thing we did before. We have a pooled group that's it, and then we're going to sign that transaction. And once we've done that, then we're going to go. I've got some logic in here to write a dry run file that could be used for debugging, and this is a little bit of the logic here in the dry run. We're going to go ahead and append the transaction, the app, the accounts all go into the dry run. And then we continue on, and then boom, there's your lyrics that get logged out. So that's some pretty cool stuff there in the way of PyTeal support, and a lot of tools is the bottom line that are available for you. So let's wrap up this session here. I've got some resources for you as well. You've got the ability to sign up for the developer newsletter. Ryan publishes on a weekly basis. You can see all the different new things that are in the developer site. And also we took a look at the ecosystem projects as well, and frameworks. These are all in the ecosystem. This Bounty is the one I had mentioned here, this game studio track. 150,000 algos, and algos I think are running about a couple of dollars loosely, so that's a lot of money. And the Gitcoin, you go out there and you can see all the different other bounties that are available to you as well. We do have grant programs for those of you that come up with a great solution here and you want to go further with it during this hackathon. These are funds that you can get that are available through the Algorand Foundation. Algorand Foundation is responsible for token economics and ecosystem growth. Ryan and I both work for Algorand Inc. So that is all about technology and SDKs and tools. And so a lot of great community leaders out there. If you want to become a community ambassador, Algorand ambassador, contact Stephen at algorand.foundation. He'll give you more information about that program. A lot of great dev office hours coming up. These are some of the ones we've had in the past here. So again, go out to algorand.com/developers and sign up. This is your hackathon, and enjoy it. Looks like we're going to be finishing up in January 11th. So get cracking, and I wish you all the best of luck in building your solutions. A couple of resources here as well. We've got the developer portal and Discord server. Make sure you click on this link or take a picture of this right now. And so you have this to go ahead and do the invite. We covered a lot of ground here today on a Monday morning, and including information about blockchain basics, what blockchain is all about. And then, what can I use it for? What are some of the examples of use cases for building blockchain? You'll see quite a few of them listed out on our site here. So that's another great link to have you take a look at to get yourself some ideas on the stuff you're doing. And then finally, if we go back to the deck here, we gave you a lot of information about some getting started tools and some great IDE tools and all the SDKs, as well as we gave you a lot of good demos there too. So, all right, great. I'll stop sharing then, and everybody, best of luck. We'll see you tomorrow.
All right, have fun building on Algorand.